Okay, we're reviewing the assignment I gave last time. I told you I'd do one problem from each section. Someone asked for number 7. The net sales of a company are shown in the graph below. Estimate the average rate of change for 2007 to 2009. What is the problem you're having with this one? The graph what? Yeah, the graph doesn't go that far. So what would you have to do? You're going to have to extend it out because the graph looks something like this. You do have to guess. You got to estimate what it's going to be. So, your graph cuts off somewhere right in here. The arrow does. But you're just going to have to say, okay, if it continues this pattern, and we know it's going to get steeper and steeper, so you're going to have to kind of curve it a little bit. And then you're going to have to extend this line up a little bit more, extend this line out a little bit more. Actually, that line's fine. Because you have to estimate between 2007 and 2009, right? So if you were estimating, and you got to look at the scales, how they are. I mean, down here you had 16,000, then you had 32,000, 48,000. I had to write in several more of these. I had to write in 80,000, okay? And you had to go up a little bit higher. And it was between 7 and 9 out here. What I did is I put a line up going like this, line up going until I hit right there, and then I put a line there and a line there. Okay? And I calculated the, I know this is going to be 2. I know this horizontal distance is going to be 2. So when I'm calculating the slope between this point and the point that you estimate up here, I know that the horizontal distance is 2. I just got to calculate the vertical, find the rise over the run, find my slope, and I have my answer. Okay? So you just have to extend it out yourself and do that. It says estimate. It doesn't say you have to have the exact thing. It says estimate. So, but, I mean, it needs to be close estimate. It needs to be a logical estimate. It needs to make sense based on what you have there. So go ahead and do that one on your own. So if you guys look at practice exercise B that's on the next page, it asks you to fill in those tables. That's pretty simple. Okay, I would just make sure your numbers are accurate. But then, down in practice exercise C, you're going to use those 3 tables. And so, for example, on practice exercise C, you had problems 1 through 6 right there. Let's choose one. Let's choose like 3. Number 3 on that one. You had to find f of x, g of x, and h of x. You had to find the average rate of change on each of those functions on the interval -2 to 5. Okay, you're on practice exercise B and C. Okay, you had to fill in the table on practice exercise B, then you have to go to practice exercise C. So, if you look at the functions on each one of those, we know that the function f of x is equal to 2x. What kind of function is that? Okay, linear. And g of x is this kind of a function right here. It's x squared. What kind of function is that? Quadratic. And h of x is 2 to the x. What kind of function is that? Exponential. So you have a linear, quadratic, and an exponential. And so you had to calculate the rate of change. So if you looked up at your table, -2 to 5, so -2 came out, I mean, its y value is -4, and if you put 5 in, it was 10, right? You calculated the rate of change between those, average rate of change by doing the slope, and we get 14 over 7, which is equal to 2. So we know that the average rate of change on this one between those intervals is 2. Does that make sense? And then we go to g of x. And if we put those numbers in for x squared, we got negative 2 comma 4. If you have your table filled out, and 5 comma 25. 25 minus 4 is 21. And negative, and then 5 minus a negative 2 is 7. So your average rate of change on that one was 3. And then you went to the next one. And you found, if you put negative 2 in there, 2 to the negative 2 power, let me just remind you, is equal to 1 over 2 to the positive 2 power, which is 1/4. So we have negative 2 comma 1/4 is 1 point. And the other point is 2 to the 5th power, which is 32. So 5 comma 32. If you calculated the slope right there, 32 minus 1/4 is 31 and 3/4, right? 31 and 3/4. 5 minus a negative 2 is 7. So if we take 31.75 and divide it by 7, someone do that. 31.75 divided by 7. 4.536. So there's the average rate of change on that one. Okay? Now, you're going to do this for all 6 problems down there because they give you different intervals to do that for. And so you look, at the end it's asking you, determine which of the 3 functions is increasing the fastest. And you've got to answer that question. Right? Which of these 3 functions is increasing the fastest? And you're going to notice, you're going to look at your data right there, and you're going to notice that there's, on different intervals, it's increasing at different amounts. And you decide how you're going to answer that question. I'm going to let you think about that one. Part D, I would carefully plot points to graph all 3 of those functions. And then follow the directions below on calculating the average rate of change on each one of those intervals. And then use that to answer questions 1 and 2 down at the bottom. You just got to carefully make sure you plot your points well on those graphs. I would choose some points that will help you get nice graphs. And then you're going to calculate the slopes on those 3 intervals given at the bottom. And then answer those 2 questions down there. All right? Okay, this assignment is due next time. The one I gave you last time will be due on Friday. So make sure you have that done. We will correct it for right answers on Friday. Remember, we only have a 55-minute class on Friday. Okay, I'm going to give you a parent function chart, but we have 2 of them in this room right here. There's one right there. Where'd the other one go? I had another one up somewhere. Oh, one on the back wall right there. Okay, and the different kinds of functions we've talked about. The only one that we haven't talked about in detail yet that we'll be talking about here soon in a couple of weeks is the logarithmic functions. The natural logarithmic and the logarithmic functions. Okay, but we'll be talking about those in the next couple of weeks. Every other function you have studied on there, including the trig functions. And between 9th grade, 10th grade, and this year, you have studied all those functions. And so what we're going to do right now is we're going to kind of review how to graph them by hand. I'd like everybody to put the lid on your calculator right now. We are not going to use a calculator to graph them. I need you to try to understand what they basically look like and then be able to plot some points that will help you kind of get a general idea of what the graph looks like. So we're going to start simple. We're going to start with y equals 2x plus 5. Okay, you should all know the simple way to graph that. I'm going to give you a minute. Go ahead. So if I was doing this, you guys, in your notes today, I would write notes down on each one of these. We're going to start with the linear graph. So you might want to mark your notes, linear graph. Then we're going to go on to quadratic, polynomials, polynomial equations, and so forth. Square root functions, absolute value, reciprocal functions or rational functions, exponential, logarithmic. We'll talk about logarithmic briefly. Sine, cosine, tangent, cosecant, secant, and cotangent. We'll be doing all those. But I would kind of keep a track. I think most of you guys have this one to save some time. We'll just talk about this. We know that we can write any linear equation in the form of y equals mx plus b. That's called slope-intercept form, right? We know that if it's in this form, we take the y-intercept, which is that number right there, 5. 1, 2, 3, 4, 5. That's where it crosses the y-axis. We put a point. And then from that point, we use the slope, which is this number right here. And we put a 1 under it when it's a whole number. And that gives us the rise and the run. So we know we can go up 2 and over 1, up 2 over 1. Or we can go down to the left one. We can go in the opposite direction. But that gives us the line or the graph that we are looking for. Okay, so first one is linear equations. We should know how to do those by hand and do them quickly. Okay. Okay, with quadratics, we're going to kind of start simple. Giving you x squared plus 8x plus 15. I'm going to give you 1 minute. Don't use your calculator. I'm going to see how much of the graph you can get. Go. Guys, what are some key points on a quadratic equation that we might want to locate and put a point for? The y-intercept? Okay, that's one. What else? Yeah, the x-intercepts. You got them, Hunter? Okay, hold on to that then. Good. So you should be able to get the x-intercepts. We've spent a lot of time finding those before. What else? What's another key feature of a quadratic equation? What do you mean? Okay. You can look at, we know that the end behavior by whether it's, like Trace saying, whether the coefficient of x squared is positive or negative, whether it opens up or down. Okay. What else? How about the vertex? Could we locate the vertex? And, yeah, that formula right there. Negative b over 2a will help you find the vertex. So let's write some of these down. We want to find the y-intercept, x-intercepts. We want to find the vertex. We want to know the end behavior, whether it opens up or down. Did I miss something? Is that all we talked about? Okay, so we're going to start off with the y-intercept. It's pretty easy. What is it? 15. Okay, 15. Okay, because we put 0 in for x. We get 15. It's always going to be that number right there. So if we're counting our scale in ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did I get a very good graph right there? Okay, so 15 comma 0. There's a y-intercept. Okay. What about x-intercepts? How do you find those? Hunter, how did you find them? Okay. So he did it by factoring. We learned how to do it by factoring, by quadratic equation, by completing the square. Okay. So we've learned how to do that. So he factored this one. This one factored pretty nicely. Okay, if we set y equal to 0, And he factored that. We know that 5 times 3 is 15 and 5 plus 3 is 8, right? So that one factored pretty nicely. I mean, how do I use those factors to find the x-intercepts? Okay, good. So we set each factor equal to 0. So we get x equals -5, x equals -3. So there's our two x-intercepts, -5 comma 0 and -3 comma 0. Looks like we're going to need to remove this stuff right here. Okay, so we have -3 comma 0 and -5 comma 0 are two more points. Okay, what about the end behavior here? What do we know about the end behavior? It's positive, it opens up. We can kind of tell by the 2 points we already have that it's going to open up as well, right? So is the vertex going to be above or below the x-axis? Okay, below the x-axis, so we know that. We learned that little formula you guys mentioned before, x equals -b over 2a for helping us locate the vertex. So the opposite of b would be what? What? Negative what? -8. And 2 times a would be what? 2. So that's going to give us -4 as our x-coordinate. Okay, and that also tells me that the axis of symmetry is right there, doesn't it? That tells me the axis of symmetry is right there. I could have told by just going halfway between the two x-intercepts as well. So I know that -4 is my vertex x-coordinate. How am I going to get my y-coordinate of the vertex? -4 comma what? We know it's down here somewhere. How am I going to find that point? Yeah, just plug it in. So -4 squared is 16. 8 times -4 is -32. Plus 15 is going to give us what? Negative 1, isn't it? So -1 is where my vertex is, at -4 comma -1. Could I use that line of symmetry to find me another point? Huh? Well, what about, I have this point here, so how does this point in the axis of symmetry give me another point? Yeah. So if I go to -8 comma 15, I'll have another point right there. It just reflects across this x-axis right here. I mean, that axis of symmetry. And there's a point. So we're ready to draw on our graph. Huh? Then we have a graph that we can feel good about. Okay? So that's how we graph a quadratic equation. Okay, we know that the parent square root function, like y equals the square root of x, begins at 0 comma 0, and it's a half of a parabola, but it's been turned horizontally rather than vertically. Okay, that's because the square root function is the inverse of the quadratic function. So let's say we wanted to graph something like y equals the square root of x plus 2 minus 3. How would I graph that? What are some key features of that? I'm going to give you guys a second to play with that, and then we'll talk about it. See what you can do. Okay. So if we are doing this one right here, we've done two translations, haven't we? Okay, because we know the parent function's at 0, 0. So we can use the fact that x plus 2 is inside the function, right? When it's inside the function, it does a horizontal translation. Moves it left or right. Do you remember if it's x plus 2, which way it moves it? To the left. So it's going to move left 2. So we're going to start right here. We're going to move 2 to the left because we studied this a while back ago. We talked about it. If it's inside the function, it goes the opposite direction of the sign right there, of the sign, okay? And then the -3, what does that do? Yeah, it's a vertical shift or translation down. So we're going to go down 3. 1, 2, 3. So that's going to be our starting point, right? Okay, so that's our starting point. Left 2 and down 3. Now, you guys, if you go back up here to this function right here, if I put 1 in for x, the square root of 1 is 1. So if you put in 1 for x, you get 1. In other words, if I start at the parent function, it goes right 1 and up 1. Well, guess what? Since we did a translation, doesn't it stay rigid? Doesn't it keep its shape? So where's another point I can write down? Yeah, I can go right 1, up 1 right here to find another point. Now, I like to use numbers that are perfect squares. So what's the next perfect square after 1? 2. The square root of, okay, 4 is. Okay, so the square root of 4, so if I put 4 in there, the square root of 4 is 2. So I'm going to go over 4 and up 2. So from this point that we started with, we're going to go over 1, 2, 3, 4, up 2. What's the next perfect square? No, before that. 9. And what's the square root of 3? Of 9 is 3. So we go over 9, up 3. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. So we're getting an idea of what the graph looks like. There it is. Okay? Next one's going to be at 16, 4 over, right? That's how you do a square root function. Basically you can choose you can make a table of values and look at that. Okay? So there's a square root function. What if I would have put a negative out in front here? It would have flipped it over the x-axis, right? Okay, if I replace that x with negative x, it would have reflected over the y-axis. Would have gone back this way. Okay, so those are some things. By the way, what's the domain of this function? What is the domain of this function? What numbers can you put in? X is greater than or equal to what? Yeah, because this function only exists to the right of -2. Trayson just said only perfect squares. Well, actually, Trayson, we could put in 3. The thing is, the square root of 3 is an irrational number, so it's not going to be a whole number. So it's not going to be right on the line. It's going to be just a little bit below where those 2 lines cross. Does that make sense? It's still there. I just didn't choose them because they're not as easy to graph. Okay? So you can choose any number you want to plot your points, but you're going to get an irrational number to plot, and it's not as easy to do. But you can use them. You can estimate, and you can use those irrational points. Okay? What does the parent function, y equals absolute value of x, look like? Looks like a V shape, right? It's, if you remember right, when we talked about it before, if you take the absolute value of a linear equation, y equals x is actually the line that went down like this. This line has a positive slope, goes through 0. Its y-intercept is 0. Its slope is up 1 over 1, up 1 over 1, right? And that would have been the equation. But as soon as you take the absolute value of it, every time we put a negative value in for x, like -2, instead of going down 2, the absolute value of -2 is +2, so it flips it up. So now we have a positive, and so it just flipped this over the x-axis. The part that's negative, it flipped over the x-axis, and it made a V shape. Okay, that's where you get the V shape from. You can take the absolute value of quadratic functions. Okay, it's just that the part below the x-axis is going to flip over the x-axis and become positive. Okay, so you can take the absolute value of any equation. So like these functions, probably the best way to do it is to think of a line and graph the line and then do a vertical shift. So let's say I gave you this equation right here. Y equals the absolute value of x minus 4 plus 1. I'm going to give you guys a minute. See what you can do on this. Okay, so let's look at it this way. I am going to draw the parent function, graph the parent function. Has a slope of 1. So over 1, up 1, over 1, to the right 1, up 1, or to the left 1, up 1. You can keep going that way and you can get that function. Whoops. Need to group these. Whoa. That didn't work either. Never mind. Okay, so I'm going to erase that and redo this so I can move this function. Oh, that'll work. Okay, so there is my absolute value function. And I have right over here, there's a translation taking place, two translations. A horizontal shift right here. The x minus 4, which way does that shift it? To the right, 4. And what way does this plus 1 shift it? Up 1. So I'm going to shift it. I'm going to take it and go 1, 2, 3, 4, and up 1. And there it is. That's all you have to do. How do I know the slope is 1? Because I know the parent function, because I know the coefficient of this x right here is 1.
So if it was like something divided by x, then that would be this.
Yeah. So, yeah, if I would have had something like 2/3 x plus 3 minus 2, something like that. Yeah, if I did this one, my slope would be up 2 and over 3. So on my parent function, I would go, okay, start here at 0, 0, and go up 2 and over, over 3. And then up 2 and over 1, 2, 3. Up 2 over 1, 2, 3. Okay, so I would get this right here. And then I'd go up 2 and over 1, 2, 3. Up 2 and over 1, 2, 3. So I would get this one going this way. Does that make sense? Okay, now, well, then I'm going to have to move it. So I'm going to move it. Which way is the plus 3 going to move it? So I'm going to move it negative, so minus negative 3 to left 3 and down 2. So it would move 1, 2, 3, 1, 2 to right here, and the slope would still be up 2 and over 3. So it'd still be right here and up 2 and over 1, 2, 3, so it'd be right here. Do you guys understand that?
Got it.
So it's just like a linear equation. If you want to graph the linear equation, you can do that and then just move it over where you need to. Okay? All right. That's all we have time for today. I'm going to give you guys the assignment. I didn't get a chance to show you all of them. We can go over a few more next